In the year 2080, Earth's thirst for expansion had finally shifted from orbital stations and Martian rovers to something much closer yet until recently, far less habitable: the Moon. What was once a lifeless sphere illuminating the night sky had now become humanity's newest frontier. The Moon wasn't just a symbolic step anymore. It had become essential to humanity's plans for survival and progress beyond Earth. The initial lunar outposts, built in the 2060s, were little more than cramped, pressurized modules dropped onto the regolith. These served as proof of concept and temporary scientific bases. But by 2080, the mission had changed. No longer were they just studying the Moon, they were building on it, permanently. The first challenge in building lunar habitats was the environment. Temperatures on the Moon swing from blistering heat of over 120 degrees Celsius during the day to frigid lows near negative 170 degrees Celsius at night. To survive such extremes, engineers developed hybrid thermally adaptive materials, multi-layered composites capable of automatically expanding or contracting, thickening or thinning, depending on the lunar cycle. The base design began with a system of partially buried domes. Excavation bots, launched weeks before the main construction crews, autonomously dug out shallow craters. These provided natural insulation and protection against micrometeorites and radiation. Each dome was then anchored into the regolith using electrostatic binding, an innovative method that used directed electric currents to fuse lunar dust into solid foundations. The construction materials themselves came not from Earth, but from the Moon. Lunar regolith, previously seen as an obstacle, had been transformed into a resource. Using microwave Cinnaringa process that melts the fine dust using concentrated beams of microwave energy builders created bricks, tiles, and even structural beams right on the lunar surface. This process eliminated the astronomical cost of hauling construction supplies from Earth's gravity well. Water, always the limiting factor in any extraterrestrial settlement, was extracted from permanently shadowed craters near the poles. Robotic drills operated continuously, boring deep into ice deposits. The ice was purified and stored in insulated underground reservoirs. Not only was it vital for life support, but it was split into hydrogen and oxygen using solar-powered electrolysis systems, supporting breathable air and fuel reserves. Energy was another critical need. While nuclear microreactors provided reliable baseline power, the majority of energy came from modular solar farms deployed across the sunlit highlands. These farms used directional tracking panels that automatically rotated to follow the sun's slow arc across the lunar sky, ensuring constant energy generation during the long lunar day. Inside the habitats, life was a delicate balance of automation and human adaptability. Closed-loop ecological systems recycled everything: air, water, even waste. Vertical hydroponic towers lined the inner walls of the habitat domes, growing food efficiently in stacked layers. LED arrays, tuned to specific plant-responsive wavelengths, mimicked Earth-like conditions to maintain crop productivity. Artificial gravity remained a challenge. Without it, long-term residents risked bone deterioration, muscle atrophy, and cardiovascular strain. To address this, central centrifuge corridors were introduced. These rotating sections created gentle gravitational forces that allowed inhabitants to exercise and acclimate their bodies in daily cycles. It wasn't perfect, but it significantly reduced health risks. One of the most striking aspects of the habitat was its silence. There was no weather, no insects, no ambient noise beyond the soft hum of life support systems and the occasional thud of regolith settling. For those who lived there, it was eerie but calming, a stillness that made every word spoken and every action taken seem weightier. Communication with Earth was near instantaneous, thanks to a network of relay satellites in cislunar orbit. Messages, video feeds, and data traveled back and forth constantly, keeping the lunar team connected with mission control and families below. But psychologically, the separation was still profound. Despite the ease of communication, the distance could be felt in the delay of physical contact, in the awareness that a rescue or supply mission would take days to organize. Yet, life on the moon had begun to take on a rhythm. Shift rotations structured the day science crews performed regolith analysis and astronomical observations during daylight hours, while engineers maintained infrastructure and life support systems. Educational modules were available for younger residents born on Earth but brought to the moon for long-term family unification. Even cultural and leisure activities were developing lunar painting classes, low-gravity gymnastics, and even zero-G musical performances in specially designed acoustic chambers. The second-generation habitat, known as the subsaline arc, was already under construction. Unlike the surface domes, it would be entirely subterranean, carved into a natural lava tube discovered beneath the Mare Tranquillitatis. These tubes, remnants of ancient volcanic activity, offered perfect shelters naturally shielded from radiation and temperature swings. They required minimal reinforcement. Once hollowed out and sealed, they could host hundreds of residents in sprawling modular corridors. From a scientific perspective, the moon had become a gateway to the rest of the solar system. Its low gravity made it an ideal launch site for deep space missions. A propulsion platform was being developed in orbit, a catapult-style electromagnetic launcher that would accelerate spacecraft to Mars and beyond without the need for traditional rockets. Every part of the lunar base supported this effort. Mining operations refined metals for spacecraft frames, chemical labs synthesized fuel components, and observation towers tracked deep space weather. Politically, the lunar habitat had sparked new global alliances. No single nation owned the moon, and the base itself was run under a neutral intergovernmental council. Contributions came from Earth's major powers, as well as newly spacefaring nations. Every habitat module bore insignias from multiple countries, and every meal was a cultural blend, reflecting the unity or at least cooperation that space demanded. There were setbacks, of course. A radiation storm in mid-2079 forced a full lockdown, sending residents into hardened bunkers for over 48 hours. One airlock system failed during early testing, depressurizing a storage corridor and destroying valuable supplies. Psychological strain claimed its toll, requiring constant monitoring and support. Still, each problem became a lesson. Each scar became part of the base's growing history. Education was prioritized. A new generation of children born during the late 2070s on Earth had been prepped since birth to become moon dwellers. Their schooling involved not just Earth science, but lunar-specific knowledge: how to navigate the surface with magnetic boots, how to recognize early signs of decompression, sickness, how to operate remote drones for crater exploration. They spoke not just one language but many, and their thinking was already planetary, even interplanetary. By late 2080, the lunar population crossed 300. It wasn't much, barely enough to fill a medium-sized village on Earth, but it marked a turning point. Humans weren't just visiting anymore. They were living, adapting, and beginning to think of the moon as home. Looking forward, expansion was inevitable. The dark side of the moon, long shielded from Earth's radio noise, was being surveyed for the construction of an enormous radio telescope. Plans for a lunar elevator linking orbit to surface via tethered carbon nanotube cables were being drawn. And beyond that, preparations for a Mars staging outpost were underway, with the moon acting as a midpoint resupply station and research hub. The moon, once silent and dead, now hummed with life. Each dome, each corridor, each breath taken beneath its surface was proof humanity had taken root in another world. Not as conquerors, but as caretakers of a new beginning. In the soft, silver glow of Earthrise, one could stand within the habitat's observatory dome and look back at the distant blue sphere. It no longer felt like the center of the universe. It was the origin, the past. The moon was the present and, perhaps, the gateway to all futures yet to come.